Hello again, I am your host Argyros Argyridis. In this video, we will see the third step in OrthoPhoto IO orthorectification process, the targeting of ground control points. While fiducial targeting restores the image interior orientation by providing GCP coordinates and solving the respective model, we can have geodetic coordinates for every point in the image. OrthoPhoto IO requires a minimum of 4 targeted GCPs for the process. The geodetic coordinates X and Y can be acquired either through the available cartographic backgrounds or directly by the user. Height information can as well be provided by the user, otherwise it can be acquired from the digital elevation model that is going to be used, either the system one or the one uploaded by the user if any. Our first step is to locate and focus on the broader region where our image was acquired. In this tutorial we are going to use the Greek cadastral WMS as a source for our geodetic coordinates. Each point height will be acquired automatically by the system from the built-in digital elevation model. This digital terrain model was acquired between 2007 and 2009 for the whole Greece, and now it's provided by the Greek Cadastral Office. Now let's find our first point. To ease targeting, we can rotate the image to make its features having a similar orientation with the reference via the rotate slider. We can switch between Bing Maps and the Greek Cadastral WMS via the menu in the upper right corner of the right map. To mark it, we need to press the Start Targeting GCPs, which is the first button in Step 3 section. Then we need to click the same point first on our aerial image and afterwards on the reference map. Let's continue to provide some more points. Keep in mind that since we are using a digital terrain model for the orthorectification process, to achieve a satisfactory result, we should target objects which are close to the ground, such as roads, pavement, and large rocks. After we have provided 4 or more GCPs, the system automatically locates and fetches the corresponding DEM for the region of interest. We can notice that additional options become available on Step 3 toolbar, which allow manipulating the available DEM. Now we can select which DEM we are going to use. Of course, we have only the system DEM available since we didn't provide any. Let's target some more points. Well, point 6 is not looking too good, so let's delete it by pressing the red X button located in the coordinates table. Now we should have enough points. We will press the Stop Targeting GCPs to avoid adding more points by mistake. By pressing the OrthoRectify option, the system will provide a preview of the final result along with the overall RMS error. Since the output is a preview, the image appears to be pixelated. By changing the opacity of the orthorectified image, we can visually compare the result with the reference imagery. We can see that our result is not satisfactory. We have a relatively high RMS and also our orthorectified image does not match properly with the reference. Let's improve it a bit by adding some more GCPs. Here is a region where a significant offset is observed. We will target some points here and recompute the result. Although we targeted good enough points, the RMS was increased. Let's check the RMS error of the individual points, eliminated one with high RMS, and see what happens. So, we will eliminate point 3 from the computations by unticking the active option. Note that this does not delete the point, only blocks it from being used by the orthorectification algorithm. Our RMS error did not improve significantly, but overall our ortho image seems to better match with the reference image than previously, as indicated by our various visual checks. Why this is happening is a point for discussion, however let's keep for now that our targeting is not optimal. Normally, targeting GCPs requires a good distribution over the entire surface of the image. However, we already achieved a very good result even by using very few points and without utilizing very precise GCPs. Our horizontal information was acquired from a WMS and vertical information from a DTA model generated through automatic matching. So there is plenty of room for improvement here. If we want to achieve good accuracies, then the best option is to identify points existing on our imagery and go and collect data in these locations either with a GPS total station or other approaches. Furthermore, we can measure distances either between 2 points or a path on the produced orthoimagery via the Measure on Map tool. To start, click one time on the map and also to add points to the path. And do a double click on the final point. By pressing the clear measure, we can remove the measurement paths from the image. We can also visualize the DEM that we are using by pressing the toggle DEM view button and setting the orthoimagery's opacity to 0. Finally, to hide and show our ortho image, we can press the toggle ortho menu. Of course, to toggle the OrthoPhoto, we need to set its opacity to a value greater than 0. That's it for now, thanks for watching. See you on the next and last video of this series where we will see how we can produce a final orthoimagery product. Until next time.